In this video, we're going to go over the next operations of what we do with rational expressions. So we've already talked about what simplifying rational expressions looks like. Now we're going to talk about multiplying and dividing. The last two will be adding and subtracting, and we'll fill those boxes in another day. Today is the bottom two boxes. So to begin, we're going to look at multiplying rational expressions. I'm going to type out our notes again. This box is not as full as last time. You can see the notes that we've already taken above, but we are going to go ahead and fill this box in and then do dividing, and then we'll get to some examples. So the first, as we talked about before, is that we always factor, and now we're going to add to that simplify. I can spell that right. First, we always factor and we always simplify first. That's a huge part of all rational work, is that we always want to factor it. And now that we know how to simplify, we always want to do that as well first. We're also going to multiply the numerators. Help if I put 1n in there. And then the other part of that is that you multiply the denominators. The way I say this is tops with tops, bottoms with bottoms. That's basically the gist of multiplying rational expressions. So the tops will multiply each other, the bottoms will multiply each other. They don't do anything funky. There's no crossing or anything crazy like that. The goal is to go from however many rationals we're multiplying, usually it won't be more than 2 or 3, down to one single rational. So you should start with 2 fractions, maybe 3 fractions, and end up with just one single fraction at the end. So you multiply those tops together, they join together on one top of a fraction, and the bottoms will multiply together and join together as one bottom of a fraction. So tops with tops, bottoms with bottoms. And then the last thing we're going to say is that we can only cancel factors, not terms. Sometimes after we are done with our multiplication, we will have some things that we can cancel afterwards. So canceling stuff afterwards is a very important part of multiplying. You always want to have as simple a rational as possible. Now we're going to look at dividing. So in the dividing rationals box, we're going to fill in these notes, and then we'll get to some examples. So for dividing rationals, it's basically multiplying with one step before. So in order to divide, we're going to multiply. Let me make sure my box is the right size first. Multiply. There we go. By what's called the reciprocal of the second fraction. Reciprocal to me just means flip. So I would put flip in parentheses right after that. So you're going to multiply, but what you need to do before you actually multiply is take the second fraction and flip it over. Always change to multiplication first, then simplify what you have. And as always, make sure to simplify and factor completely. So in every single thing that we do, simplifying, multiplying, dividing, when we get to adding and subtracting, we're always going to simplify and factor as needed. But specifically for dividing, it's just a multiply problem, so you can look at those notes as you go through it. But the reciprocal is the first step in order to actually make it into a multiplication problem. Now we're going to look at worksheet 3 to practice with multiplying, and then we'll get to worksheet 4 to practice with dividing. So keep in mind, my catchphrase for multiplying rationals is tops with tops, bottoms with bottoms. So I'm going to go ahead and do the even problems with you this time. And so if you start with number 2 on worksheet 3, we've got x squared y over z squared times z over xy. So my first step here is to just go straight across. So the tops are going to multiply straight across and the bottoms are going to multiply straight across. So I'm just going to put all the tops in one fraction, x squared y and z, and then z squared x and y. So I've made it into one fraction. Now I just have to simplify it. So we've already done some simplifying stuff. Let's start with what I think is easiest here. Y's match with y's. They match up nicely. They cancel out. X squared will match up with x. And there's 2 x's on top. So that means that x will be on top in the end. 2 minus the 1x on the bottom is just 1. So just 1x on top. And then finally we have the z's. Z over z squared bigger. So z will end up on the bottom. And your final answer would be x over z. So all we did there was multiplied 2 fractions. The tops combined and multiplied together. The bottoms combined and multiplied together. And then we just canceled and simplified like we did before. Number 4 has x squared minus 1 over x times x squared over x minus 1. Let's go ahead and multiply straight across. We have x squared minus 1. I'm going to put that in parentheses to show that it's multiplying with the other x squared. And then x is going to multiply with x minus 1, which I will also put in parentheses. So keep in mind factors versus terms. In this parentheses, we have the minus 1 as a term. And then outside, we have a x as a factor. So the x and the minus 1 inside this parentheses are both terms, but outside, because they are multiplying, the x is a factor. So be careful with terms versus factors here. So now you can see we might actually need to factor this. We have x squared minus 1 is a difference of squares. So I'm going to factor it as x minus 1, x plus 1, and then just keep my x squared. And we've got x minus 1 times x plus 1 times x squared over x times x minus 1. So I can obviously see that the x minus 1s will cancel. And then I can also see that I have the x and the x squared. So there's more x's on top. So my final answer is going to leave me with an x on top. And 2 minus 1, that's just going to give me 1x. And then also leaving me with the x plus 1. So my final answer is x times x plus 1. Looking at number 6 now, we have a squared minus 4 times a minus 1. Sorry, a squared minus 4 over a squared minus 1 times a minus 1 over a minus 1. So your first thought might be, oh, let's do a squared minus 4 in parentheses, multiply it with a minus 1, and then do a squared minus 1 in parentheses and multiply it with a minus 1. But take a second and think about that. We have 2 fractions, and we always want to try and use as simple a fraction as possible. A minus 1 over a minus 1 cancels. So if we get rid of that, our fraction becomes a squared minus 4 over a squared minus 1 times 1, which we don't even need. So it's just a squared minus 4 over a squared minus 1. So from here, you might already know this, but if we factor these, we'd want to see what cancels, but we're not going to get any matches. So the only thing that simplified and canceled was the a minus 1 in the first fraction. So your final answer is just a squared minus 4 over a squared minus 1. So in this case, we didn't actually need to multiply. We just needed to simplify it first. Looking at number 8 now, we have to do several different versions of factoring here. So z squared minus 6z minus 7 is the first thing I will factor. So that's going to factor with an x puzzle in 2-step factoring. what multiplies to -7 and adds to -6. That's going to be -7 and 1. So the top will multiply as z minus 7 times z plus 1. And then the bottom, that just has a GCF, greatest common factor, of z. So z plus 1 is what's left inside of my parentheses. But what I'm actually going to do here is I'm going to draw my line all the way across and just put the factors for the second fraction right next to those factors that I just wrote. That's basically just multiplying. So we have z squared minus z, that's got a GCF of z, and what's left is z minus 1. And then the bottom fraction on the right has a GCF of 3. When that factors, all that's left is z minus 7. So now we've got all of our factors, parentheses, individual things, and we can go ahead and cancel anything that matches. So z minus 7, that matches there. We have a z plus 1, those match, and we have a z on the outside. So remember, factors have to match exactly, and then things outside of the parentheses, they can cancel. So what we're left with for our final answer is z minus 1 all over 3. So that is the front. Let's go ahead now and take a look at the back. So here's 10, 12, and 14. Once again, I'm going to do the even numbers. So we've got x plus 8 over x squared minus x minus 12 times x squared minus 6x plus 8 over x squared plus 6x minus 16. So once again, tops are going to multiply with tops, and the bottoms are going to multiply with bottoms, but we also need to factor and all that fun stuff that is required in simplifying. So I'm going to factor everything first, and then I will multiply. So x plus 8 does not factor. X squared minus x minus 12, that factors as x minus 4x plus 3. And then that's going to multiply with x squared minus 6x plus 8 on top will factor into x minus 4x minus 2. See if I can get my 2 to actually write here. There we go. And then the bottom, x squared plus 6x minus 16 will factor as x plus 8x minus 2. So last time I factored and wrote everything into one fraction at once. This time I did not. But what you might see is that you can actually cancel things ahead of time. So in this case, on the far right, we have x minus 2 over x minus 2 in the same fraction. You can go ahead and cancel that right now. So now we multiply straight across. So we're going to go tops with tops. So x plus 8 will multiply with x minus 4. So I'm going to put both of them into their parentheses and just put them together as one top. And then the bottoms go with the bottoms. So all the parentheses across the bottom will multiply together. Just write them right next to each other. X minus 4 times x plus 3 times x plus 8. Now anything else that matches, we can cancel. X plus 8 cancels because they both match. And our final answer will be anything that's left. X minus 4. Oh, I missed one. Sorry. The x minus 4 also cancels. So be careful. Make sure you cancel everything that you can. So in fact, the only thing that's left is an x plus 3 on the bottom. Let's make that a better 3. When everything cancels on the top, it doesn't just become 0. You can't just leave it blank. You have to put a 1. So our final answer is 1 over x plus 3. So now looking at number 12, we have x squared minus 4 over x squared minus 2x plus 1 times x squared plus 5x minus 6 over x squared plus 4x minus 12. This, I'm just going to go ahead and fly through all the factoring. So we've got x minus 2 times x plus 2 over x minus 1 times x minus 1 times x plus 6 times x minus 1 all over x plus 6 all times x minus 2. All right, so I've written out all the factors this time. You can see them in two separate fractions, and I'm going to show you one of my shortcuts here. When you have all the factors written out, you're welcome to start canceling things that you see that match. But before I do that, I just make one big fraction. Everything on the top multiplies with everything on the top, and then everything on the bottom multiplies with everything else on the bottom. So now you can go ahead and cancel anything that matches exactly. For instance, x plus 6, those are good. X minus 1, those are good. And then x minus 2 and x minus 2, those are good to cross out as well. So it's just a step saver. Instead of having to rewrite everything into one total fraction, you can just factor it and then cross everything out. So our final answer this time is x plus 2 over x minus 1. Keep in mind, I canceled an x minus 1, but you can only cancel each x minus 1 that matches with another exact x minus 1. So I could only cross out one from the top and the bottom. The second one stays. Alrighty, on to the last one from this page, number 14. We have x minus 1 over 2x minus 3 times 4x minus 6 over 1 minus x. So I see one thing I can factor here, and I'm going to use another shortcut to factor this. I'm just going to do it right above it. So 4x minus 6 in my second fraction has a GCF of 2. And what's left is not just x, it's 2x minus 3. So 2 times 2x minus 3 is that top right fraction. If you just want to scratch that out now, knowing that it's gone, there you go. So we've got x minus 1 times 2 times 2x minus 3, because tops go with tops. And then bottoms multiply with bottoms. 2x minus 3 times 1 minus x. We can see 2x minus 3 actually matches, so I'm glad we factored there. I don't necessarily see anything else that matches on first look, but we have x minus 1, and then left on the bottom we have a 1 minus x. So those are the same, minus the fact that they're opposites. X and 1 have switched here. So because they're opposites, they make negative 1. So we're going to cross out x minus 1 and 1 minus x, but we're going to leave behind a negative 1. So negative 1 and 2 is all that's left, and those will multiply together. So your final answer is just negative 2. We're going to move on to dividing now. So worksheet 4 is what we're looking at, and I will do the evens once again for this. So let's go ahead and look at number 2 here. We've got c squared plus 2cd over 2cd plus d squared divided by c to the third plus 2c squared d over cd plus d squared. So I'm sure you're thinking, wow, there's a lot going on there, and if we're doing division with fractions, this is going to be difficult. Trust me, it's actually not too bad. It's basically just multiplication with that one extra step. So the extra step is we take the second fraction and we flip it over, and then it becomes a multiplication problem. So c squared plus 2cd doesn't get touched. 2cd plus d squared doesn't get touched. Change to a multiplication problem. So instead of division, we want multiplication. And in order to do that, we have to flip the entire second fraction. C to the third plus 2c squared times d all moves to the bottom. And there you have it. Now we just go through the steps like we just did with multiplication. So let's factor. On the top left, we have a c as a GCF, so it's c plus 2d. On the bottom left, we have a d as a common factor, so d is pulled out, and we're left with 2c plus d, and we're multiplying across. So the right side on the top, we have a d as a common factor. So we have c plus d. And then on the bottom right, we have c squared as a common factor. So that'll leave us with c plus 2d. I'm going to go ahead and use my trick of making one big fraction when I multiply, and now I can cancel anything that matches exactly. So I see a d on the outside of a parentheses on the top and the bottom, so those can cancel. I see a c plus 2d, those can both cancel. And then I also see c and c squared. So if you remember back to our exponent rules, those will cancel, and the c will stay on the bottom on the outside. So we have one c left over because 2 minus 1, I'll put that 1 there just so you can see it, is 1, and the bigger exponent was on the bottom. So we're left with c times 2c plus d on the bottom, and on the top, we're left with just c plus d. And that's our final answer. So that flip wasn't all that bad. Looking now at number 4, we have another division that we want to turn into multiplication. I'm going to factor and do the flip at the same time. So the first one's not too bad. Everything's in the same spot. So a squared minus a minus 20, that's going to factor as a minus 5 times a plus 4. Awesome. Then the bottom, we have a squared plus 7a plus 12. That's going to factor as a plus 3 times a plus 4. And just right away, I see a plus 4 over a plus 4. I'm going to cancel it. Now to the second one, I am going to factor and flip at the same time. So I'm flipping this entire fraction. So the top is going to be my bottom. So I'm factoring the top of what's printed, but now it's going to be the bottom of this problem. So a squared minus 7a plus 10 factors as a minus 5 and a minus 2, and that goes into the bottom of your fraction. The top of what's left is the bottom of the original fraction because we're flipping it. So a plus 6 times a plus 3. I don't see anything that can cancel there, but it's a multiplication problem. So I have one big fraction, and now I can cancel any top that matches with any bottom. A plus 3 matches with this a plus 3. A minus 5 matches with this a minus 5. And our final answer is a plus 6 on top and a minus 2 on the bottom. Everything matched up and canceled nicely. Now on to number 6, the last one here on this page. We have a to the third minus 6a squared plus 8a over 5a, and that's going to be divided by 2a minus 4 over 10a minus 40. So once again, I'm going to do what I just did. I'm going to factor and flip the second fraction at the same time. So first fraction, pretty straightforward. The top stays where it is. This factors as a, because there's a GCF of a on all of those. So a squared minus times, so a times a squared minus 6a plus 8. That parentheses still might be able to factor, but for now I'm just going to leave it like that. And then 5a doesn't factor. But conveniently, I have an a and an a. I'm just going to go ahead and cross those out. Now I'm multiplying because I'm changing it to a multiplication problem. But in order to do that, I have to flip. So I need to put the bottom one on top. So 10a minus 40 is what it's going to go on top. But I also want to factor it. So there's a GCF on 10 and 40. So that's a GCF of 10. So I just pull out the 10 and leave behind an a minus 4. Then the top becomes the bottom. And I'm going to do the same thing, factor out a 2, and we're left with a minus 2. Alrighty. Use my trick, one big fraction. Although, have I actually factored a squared minus 6a plus 8? Let's see real quick. Can we factor it? Something that multiplies to 8 and adds to negative 6. Yep, negative 4 to negative 2. So let's factor that real quick, and then we'll make one big fraction. a minus 4 times a minus 2 all over 5 because we canceled the a's that were on the outside times 10 times a minus 4 over 2 times a minus 2. Now we'll make one big fraction and cancel any matches. A minus 2 cancels across. What about a minus 4? They're both on the top. Do we cancel things on the same? No. They only cancel if they're across from each other. So take a look on the bottom. We're multiplying 5 and 2 together. 5 and 2 multiplied together will make 10. So I'll scratch out 5 and 2. And now look, it can cancel with that 10 on top. So the 10s go away. And all that we're left with is a minus 4. And then we have 2 of them. So we're going to write it as squared. So a minus 4, the entire thing squared. Alrighty, on to the back of this sheet. We have 3 more problems, 8, 10, and 12. 12 looks pretty unique, so we're definitely going to get to 12. Number 8 says x squared minus y squared over x squared plus 2xy plus y squared divided by x minus y over x plus y. Well, the second fraction doesn't have any factoring that I can do in it, so that's going to be pretty nice. So the first one, my first fraction doesn't flip. It stays as it is, but let's factor it as we keep it. So x squared minus y squared just becomes x minus y times x plus y if we follow our difference of squares rules. And then x squared plus 2xy plus y squared, don't let that scare you. It's just x plus y times x plus y. Oh, not the square on it. X plus y times x plus y. And like I said already, we change it to multiplication and we are going to flip over that second fraction. That's all the division takes. Just flip over the second fraction and change to multiplication. Let's use our shortcut, make one big fraction. If it makes you feel better to put these in parentheses when you do that, feel free. And now let's cancel. X plus y, x plus y, x plus y, x plus y, x minus y, x minus y. Whoa, check it out. I have a red line through every single thing. When everything cancels, your answer is 1. Think about that real quick. If you have 10 over 10, everything technically cancels there. That's just 1. So your final answer for number 8 is just 1 because everything canceled after we factored it. Pretty nice answer. All right, 2 more. Number 10, we have x squared minus 4x plus 4. That will factor as x minus 2 times x minus 2. And then the bottom of that will be 3 as a GCF times x minus 2. Then I'm dividing by x minus 2. Well, how do I flip something that doesn't have a bottom or a top? Well, anything that doesn't have a bottom can be given a bottom of 1. So now we can flip it. The 1 jumps up to the top, and the x minus 2 goes down to the bottom. So now we factored and flipped, turned it into a multiplication. Let's make one big line and cancel what we can. So x minus 2 obviously cancels in the first one, but now the other x minus 2 will cancel with this x minus 2, and we are left with just a 1 and a 3 on the bottom. So 1/3 is our final answer for number 10. Number 12 looks unique, but it is unique, but it doesn't actually have to be all that complicated. It just looks a little complicated. All that's important is that the top 2 things is one fraction and the bottom 2 are the other fraction. So what I always like to do is rewrite the entire problem into a format I like. So 26c squared divided by 5c squared d. And then a fraction bar just means division. So I'll write divided by 13c cubed over 25d cubed. Could you go straight to multiplication? Yes, you could. I'm just using the division to show you how it actually breaks out. So what we'd now do is we'd take 26c squared, keep it the same, 5c squared d, keep that the same. Yes, you can cancel stuff if you see it already. Turn it into multiplication and flip over our second fraction. So 25d to the third jumps up to the top, and then 13c to the third drops down to the bottom. Now let's go ahead and draw our line. We have one big fraction where we can cancel as much as we can. So c squared matches c squared. I see a 25 and a 5. 25 divided by 5 is going to give me a 5 on top. Okay. Then I've got a 26 and a 13. 26 divided by 13 is 2. So I'll put times 2 because we're going to multiply things that are left up on top. And then the last thing I see is this d matches up with d cubed. So d cubed is bigger on top. So we need to put d up on top, and it's 3 on top and then 1 on the bottom. So 3 minus 1 is 2. So we're left with d squared. And then don't forget about the c cubed that was left over on the bottom right here. So our final answer is not 5 times 2d squared over 3 cubed. It's what's 5 times 2? The final answer is 10d squared over c cubed. Awesome.